Hello YouTube, today we're going to be looking at this circuit problem here today. We're going to be looking for the equivalent resistance and the voltage across a certain resistor with this circuit setup. So we're just going to see if we can approach this problem. So let's look at the first part. So I just redrew the circuit and wrote the key facts there. So if you notice, already kind of went through the step already. To find the voltage across a resistor, you just use Ohm's law, V equals IR. In this case, Vx equals IR. So let's figure out what I is. Well, if you notice on the right that DC dependent source over there is dependent on the voltage of across R1. And given the assumption there on the top left that was given in the problem, excuse me, we know that the G is 1 milliamp over volts, 1 per volt, and if we multiply that by Vx, we show that, oh, that's just, gives you current. The units for volts cancels and you get current, so that shows the units for current. Let's also set up how the current is flowing for this circuit. Notice how the source on the left, the current flows clockwise, and on the right, the current flows in the right loop there counterclockwise. So when we're using Ohm's law, we're going to have to take account for that current traveling in opposite directions for through the section of the circuit that involves R1. So we'd actually have to subtract the two currents because they are going in opposite directions. So the source minus the dependent current source times the resistance, which is R1, which is where we're looking for the voltage across the resistor. So now we can simply plug in the information we know. We know the current source is 10 milliamps. And now we can replace I with the GMVX, right? That was what we defined as I. And then still multiply by the 9 kilo ohms. Next, we can look at that assumption there. Or let's distribute the 9 kilo ohms first. So I'm just going to get rid of the units there. So we just got 90 minus 9 times GMVX. Now notice on the top left there, the assumption says that GM is 1 milliamp per volt. So look, we can just get rid of that. It's just like multiplying by 1, so we have 90 minus 9 Vx. So notice we have a Vx on the left side of the equation, a Vx on the right side of the equation, so we can rewrite the equation as 10 Vx minus 9, and then divide by by 10, you get 9 volts. I just realized that it wasn't 90, it said 9, not 90, but yeah. Divide by 10, you get 9 volts, so there's Vx's 9 volts. So now we have the voltage there. Let's look at the second part here. So now we're going to find our equivalent when R2 is equal to 0. So what is the equivalent resistance? We're not looking for voltage, right? Well, we already know we can use the information from part A, which is where we found Vx already. So we know Vx is 9 volts, and we know, Ohm's law rewritten is R equals V over I. Well, we have Vx, so we can find Req because we know the current source on the left is 10 milliamps. So we just plug and chug. We got 9 volts over 10 milliamps gives you 9/10, which is 0.9. And notice the units, how there was milliamps in the denominator, so our resistance will be in kilo ohms. So that's our equivalent. Finally, we got part C, which is saying, hey, R1 and R2 have the same resistance, and notice R1 is 9 kilo ohms, so R2 is also 2 kilo ohms. But wait a minute, that doesn't really matter, because the DC current source is in series with the R2 resistor, so that resistance is irrelevant. So we can still find Req, and it's actually just the same thing as what we find with part B there, finding the equivalent. So that R2 there is pretty much pointless. It's kind of like a trick question there, so watch out that because the resistor is in series with the current source, it doesn't really matter what what the resistor is, because that current source dictates how much current is going through there anyway. So the equivalent is still the same. Our equivalent is still the same. So I hope that video was helpful to you. Good luck and happy studying.